we studied in the previous class that when electron is jumping from higher energy state to lower energy state, the radiation will be emitted, photon will be emitted.
Yes, sir.
The emitted photon has energy. We studied yesterday. The emitted photon has the energy is given by h mu equal to, energy of the emitted photon will be h mu equal to, what is the formula we studied yesterday?
1 by n minus n1 the whole n square by 1 minus.
Okay. Yes, it is there in the previous page. Okay, I will show you. It is there in the previous page. This formula, 13.6 into 1 by n2 square minus 1 by n1 square. But the second formula is widely used. The second formula, the emitted photon will have a wavelength. It is given by 1 by lambda equal to r into 1 by n2 square minus 1 by n1 square. R is a constant having the value 1.09 into 10 raised to 7 per meter. Till this we studied yesterday, right? Clear?
Yes.
Okay, next is atomic spectra. Atomic spectra. Look here. Listen. The theory part I don't want to read. Okay, this theory part is not required. The atomic spectra means, listen, it is a pattern of waves or radiations. Understood? Clear?
Yes, sir.
It is a pattern or sequence of radiations having different wavelengths.
Yes, sir.
It is in the order of increasing wavelength. We get different types of radiations when the electron jumping from one state to another state. Understood? Clear?
Yes. Yes.
When the electron jumping from higher energy state to lower energy state, different types of radiation will be emitted. Okay, so listen, the different types of radiation means, listen, suppose the electron is jumping from higher energy state to n equal to 1. Understood? Clear?
Yes.
The electron may be jumping from 2 to 1, or may be jumping from 3 to 1, or may be jumping from 4 to 1, like that. The electron is jumping to the ground state. From some of the higher energy state. From a higher energy state. So we get different types of radiations. Different type of radiation means that, see, if you have a sample of hydrogen gas, if you select one atom, if you select one hydrogen atom, the electron may be there in the second energy state. But if you take another hydrogen atom, the electron may be in the third state. The next one, electron may be staying in the fourth state. So if I have a sample of hydrogen gas, excited state, suppose if we have a sample of hydrogen gas, the electron may be in the different energy states, 2, 3, 4, etc. So if the electron jumping to the ground state, we get different patterns of radiation. If the electron jumping to n equal to 1. Clear?
Yes, sir.
I mean, why we get different radiations when electron jumping to n equal to 1? Because in different atoms, some electron may be there in the second state, some may be in the third state, some may be in the fourth state. So if the electrons jumping to the ground state, we get different types of radiations. The photon will be emitted, which is having different wavelength. So the pattern of wavelength, if the electron jumping to n equal to 1, is said to be Lyman series. Okay, understood?
Yes, sir.
Lyman series is the series of radiations when the electron jumping to n equal to 1. Okay. Now Balmer series. This diagram is not required, but this name is required. Okay, this name you have to learn, and the n value also you have to learn. The diagram, this entire diagram is not required.
Okay.
The Balmer series means if the electron is jumping to n equal to 2. Jumping to n equal to 2 means from 3 to 2 or 4 to 2. Clear?
Yes, sir.
5 to 2, like that. Electron jumping to n equal to 2.
Okay.
In this case we get
Oh,
di-
like
dif-
if the electron is jumping from 3 to 2, like the last thing is 2 means it is Balmer series, sir.
Balmer series means the electrons are in the excited state if the electrons jumping to n equal to 2. Clear?
Okay, sir.
Jumping to n equal to 2. Jumping to n equal to 2 means there are various possibilities. 3 to 2 can be there, 4 to 2 can be there, 5 to 2 can be there. Understood?
Yes, sir.
For each cases we have a many wavelengths. Clear? Many wavelengths. So all these wavelengths are said to be Balmer series. Okay?
Yes, sir.
And next Pascal series. Pascal, I don't want to show in the diagram. Pascal series means if the electron jumping to n equal to 3. Jumping to n equal to 3 means it can be 4 to 3, 5 to 3, 6 to 3, like that. Understood?
Yes, sir.
That is Pascal series. Okay. And there is another series which is not given in NCERT, but NEET exam they may ask. So let me write here. Bracket series. Okay.
Yes, sir.
The number is not required. 820 nanometer. The wavelength number, that is not required. There is another pattern, bracket series. It is obtained when electron jumping to n equal to 4 from the higher states. Okay.
Yes, sir.
5 to 4, 6 to 4, like that. And finally fun series,
Okay, sir.
when the electron is jumping to n equal to 5. Okay.
Yes.
Look at this question. I don't want to delete it because to save time, let entire solution be there. I will explain the line by line. Okay, line by line I will discuss that.
Okay, sir.
A hydrogen atom initially in the ground state.
Yes, sir.
Can you wait? Okay, we can start. Okay, listen.
Yes.
A hydrogen atom initially in the ground level absorb photon which excite to n equal to 4. Determine the wavelength and frequency of the photon. It is a reverse process actually. Listen, it is a reverse process. I will tell you. If the electron jumping from higher energy state to lower energy state, photon emitted. Understood? Clear? Remember, higher energy state to lower energy state. Higher to lower. Such jumping, if the jumping take place, the photon will be emitted. Is that okay? Clear? Hello?
Yes, sir.
That reverse process can take place. The reverse process also can take place. Meaning that the electron is in the lower energy state. The electron is in the lower energy state, say n equal to 1.
Okay.
If it absorbs certain radiation, if it absorbs photon, it gain energy. Understood? Clear? Hello?
Yes, sir.
Okay. The electron in the ground state, it absorb photon, then it gain energy. If it gain energy, naturally it jump to higher energy state. Clear?
Okay.
So it is a reverse process. Okay. Remember, higher to lower jumping. Okay. Higher to lower jumping, photon emitted.
Okay.
The reverse process is what? The reverse process is the electron can move from lower to higher when it absorb energy from photon. So if this photon absorbed by the electron gain energy, it can jump to higher energy state. Clear?
Yes.
In both cases, in both situations, the 1 by lambda equal to this formula is valid. Understood? Clear?
Yes.
In both cases of jumping, this formula is valid. This is the widely used formula. Okay? Clear? Is it okay?
Yes, sir.
Okay. So 1 by lambda stands for the wavelength of the photon absorbed by the electron. This photon will have certain wavelength, that is lambda. 1 by lambda equal to r into 1 by n2 square minus 1 by n1 square. Okay, 1 by n2 square minus n1 square, where n1 and n2 are the two levels. Clear? The electron will be jumping from one state to another state. N1 and N2 represents that numbers.
Yes.
N1 and N2 they represent that numbers. So in both cases of jumping, this formula is valid. So what is our question? The electron is jumping from n equal to 1 to n equal to 4. Clear?
Yes, sir.
So what is the wavelength? What is the wavelength of the photon absorbed by the electron? Lambda is our question. Lambda. So let me use this formula. 1 by lambda equal to this. 1 by lambda equal to r is a constant. That value you have to memorize. Okay?
Okay, sir.
R is a constant. It is that value you must memorize. It will not be given in the question. R equal to 1.09 into 10 raised to 7. Okay?
Yes, sir.
1 by n1 square minus n2 square. The order of the subtraction, you need not worry. Please keep in your mind that whatever order you write, the number should be positive. Clear? Understood?
Yes, sir.
Suppose you made a mistake that instead of writing this order, suppose if you write 1 by 4 square minus 1 by 1 square, no need to worry. No need to worry. If there is a negative sign, you just reject it. Understood? The negative sign, you have to reject it. So the order of the subtraction, you need not worry. The order of the 1 minute. 1 minute. The digital pen disconnected. 1 minute. So in this formula, 1 by n2 square minus n1 square, n1 and n2 stands for 1 and 4. Clear? Understood?
Yes, sir.
So you may either write 1 by 1 square minus 1 by 4 square, or 1 by 4 square minus 1 by square. The order of the subtraction is not so important, not important at all. You have to ensure that the term must be positive. When you do the subtraction, if you get the negative number, you simply reject the negative sign. Okay?
Okay.
So one value to be substituted here, and 4 should be substituted. Okay. So the calculation, can I skip the calculation?
Yes, sir.
1 by 1, 1 by 16, that kind of that I don't want to discuss. So substituting the value, I will get the value as 1.02 into 10 raised to 7. Okay?
Yes.
So 1 by lambda equal to this.
Yes, sir.
The left side is 1 by lambda. Okay? The left side is 1 by lambda. 1 by lambda equal to 1.02 into 10 raised to 7. I want lambda, right? Clear?
Yes, sir.
Lambda, I have to take the reciprocal. I got 1 by lambda, but I need lambda. To find out lambda, you just take reciprocal. Lambda equal to 1 by 1.02 into 10 raised to 7. Okay?
Yes, sir.
Again, that calculation I don't want to discuss. Okay?
Okay, sir.
1 by 1.02 into 10 raised to 7 will be 0.98 into 10 raised to minus 7 meter. Okay?
Okay, sir.
This step is clear?
Yes, sir.
Calculation I don't want to discuss. And remember, if it is a multiple choice question, the lambda options will be in terms of nanometer. The lambda wavelength is normally represented in terms of nanometer. So the option 10 raised to 4 will not be there in the option. Instead of that, nanometer will be there in the option. Okay?
Okay.
So I got 0.98 into 10 raised to minus 7 meter. This must be converted to nanometer. Understood?
Yes, sir.
Because the option will be in terms of nanometer. So 0.98. Can I write 0.98 as 98 into 10 raised to minus 2? Is that okay?
Sir, what happened to the 15 by 16, sir?
See, I told you clearly that the multiplication and division I did not discuss. Okay, 1.09 into 15 you have to multiply. After that you have to divide by 16.
Okay, sir.
That multiplication and division I did not discuss.
That is 1.02. Sir.
Ah yes, if you multiply and divide you will get 1.02.
Okay.
So the multiplication, division, etc. I have not discussed. Okay.
Okay, sir.
0.98 into 10 raised to minus 7 meter. Is that okay?
Yes, sir.
0.98 is 98 into 10 raised to minus 2. Are you okay? That step is clear.
Yes, sir.
0.98 is 92 into 98 into 10 raised to minus 2 into 10 raised to minus 7 is there. So lambda equal to
Okay, sir.
98 into 10 raised to minus 2 into 10 raised to minus 7, 10 raised to minus 9, correct?
Yes, sir.
10 raised to minus 9 represents nano. Okay,
Okay, sir.
I explained it. Okay, 10 raised to minus 9 represents nano.
Okay.
So lambda equal to 98 into 10 raised to minus 9 meter. 10 raised to minus 9 stands for nano. So 98 nanometer. Okay.
Yes.
So you please read all the steps up to this. Lambda equal to 98 nanometer. Okay.
Okay.
Please read it. Next step. In the next step, the question is they are asking for wavelength and frequency of the photon, right?
Yes.
So this formula is the most important formula. If we have found lambda, we can easily find out frequency, because lambda and mu connected by a formula, lambda and mu connected by a equation. We studied photoelectric effect. Lambda into mu equal to c. Okay, clear? Hello. So you please memorize all the formula. I am still doubt whether you have studied the basic formulas. See, a photon will have wavelength and frequency. Every photon will have wavelength and frequency. The wavelength and frequency, their product is a fixed number. For every photon, the wavelength and frequency, their product will be a fixed number. So that if the lambda is given, we can find frequency. If frequency is given, we can find out lambda. So for every photon, lambda into mu is equal to c. Okay, lambda into mu equal to c, where c is a constant having the value 3 into 10 raised to 8. Okay,
Yes.
this formula we have already studied, so please note that. So lambda mu equal to c, please note it. I got value of lambda. Understood? Clear?
Yes.
I got lambda. Let me use this value. Lambda as 98 into 10 raised to minus 9. I got the value of lambda as 98 into 10 raised to minus 9. So mu can be written as c by lambda. Understood?
Yes.
Mu is what? C by lambda. That is written here. Mu equal to c by lambda.
Yes.
C is 3 into 10 raised to 8 by lambda is 98 into 10 raised to minus 9. Again, multiplication, division I don't want to discuss. Okay, I don't want to discuss how to divide 3 and 98. 3 by 98 you will get 0.03 into 10 raised to 17. Okay, hello.
Yes, sir.
I am skipping the calculation. Okay, to save time I am skipping the calculation part. 0.03 into 10 raised to 17. 0.03, I will explain the important parts, but not all the division multiplication I will not discuss. 0.03 is 3 into 10 raised to minus 2. 0.03 is written as 3 into 10 raised to minus 2 into 10 raised to 17. 3 into 10 raised to 15. 3 into 10 raised to 15 hertz. The frequency has the unit hertz. Okay, clear. So you please write, just go through all these steps. If you don't look at this question. Look at this question. The energy required to knock out of the electron in the third orbit of a hydrogen atom is equal to. The electron is in the third energy state or third orbit. The electron is where? Electron is in the third orbit. This has to be transferred to infiniteth orbit. If the electron move to infiniteth orbit, the electron is free. The electron is said to be free when if it move to infinity. Because if the electron is at infinity, there is no attractive force by the nucleus. So the electron, so if I want to remove the electron, if I want to knock out the electron, remove the electron, this has to be sent to infiniteth orbit. Is that okay? Clear?
Yes, sir.
So from 3 to infinity, the electron has to be transferred. The electron has to be transferred from 3 to infinity. How much energy is required for that? How much energy is required for that transferring? So the required energy is equal to the change in energy. I mean final energy minus initial energy is the required energy. Understood? The required energy for the transferring will be the energy in the final state minus energy in the initial state. The delta is our question. So final energy when the electron is at infinity, the final energy minus initial energy. Is that okay? Clear?
Yes.
The energy of the electron in the nth energy state is minus 13.6 by n square. We studied this formula. Energy of an electron in the nth energy state is minus 13.6 by n square electron volt. We studied that, already studied that. So the final energy will be minus 13.6 by infinity square, because in the final state the n value is infinity. So the final energy will be minus 13.6 by infinity square. Is that okay? Clear?
Yes, sir.
Minus and initial energy. Initial energy means energy when n equal to 3. Initial energy is energy when n equal to 3. So energy when n equal to 3 is, simply put n equal to 3 here. Simply substitute n equal to 3 here. Minus 13.6 by 3 square. Okay?
Yes.
So I hope you have understood. So final energy minus initial energy. A number by infinity will be 0. Any number divided by infinity will be 0. Okay, and I hope you have understood. So this one is cancelled. This one is 0. So this minus minus becomes plus. 13.6 by 9 electron volt is the answer. Look at this question. So all the questions are based on 1 by lambda almost. Either this formula minus 13.6 by n square electron volt. Either this formula or 1 by lambda equal to this formula. Okay, in most of the questions we require these two formulas.
Okay, sir.
Let me explain this problem. Yes, actually I discussed this, but it is a revision class. The wavelength of light emitted due to transition of electron from second to first orbit. So the electron is jumping from n equal to 2 to n equal to 1. Clear?
Yes.
Second orbit to first orbit. The electron is jumping from higher energy state to lower energy state. N equal to 2 to n equal to 1. If in that case a photon will be released. Clear?
Yes, sir.
Higher to lower, photon will be emitted. The wavelength of that emitted photon is our question. Clear? So in the case of jumping from one energy state to another energy state, the photon, the wavelength of the photon will be 1 by lambda equal to r into 1 by n2 square minus 1 by n1 square. Clear?
Yes.
So direct question, 1 by lambda equal to, the r is a constant. R is 1.09 into 10 raised to 7. N1 and N2 will be 1 and 2. Understood? Clear? Hello?
Yes.
N1 and N2 will be 1 and 2. So put N2 equal to 1, N1 as 2. Or if you change the order, no problem. If you change the order, no problem. You will get some negative number here. You simply reject it. If you get a negative number inside the bracket, you just simply reject it. So the order of the substitution is not important. If you get the negative number, simply reject it. So I put N2 as 1 and N1 as 2. Clear? So 1.09 into 10 raised to 7 into, this is 1 minus 1 by 4. 1 minus 1 by 4 is 3 by 4. So 1.09 into 3 by 4, that multiplication and division I don't want to discuss. 1.09 into 3 by 4. You will get 0.817 into 10 raised to 7. Clear? Understood? Hello?
Yes. Got it, sir.
So this is actually 1 by lambda. Okay? This is not the final answer. This is actually 1 by lambda. I want lambda. To find out lambda, we have to take the reciprocal of this. We have to take the reciprocal of this. 1 by 0.817 into 10 raised to 7. Let me skip the calculation again. 1 by 0.817, you will get 1.22. You can do the division later after the class. 1 by 0.817, you will get 1.22 into 10 raised to minus 7. This is the answer, but there is no such answer. It is, the answer is in terms of angstrom. Clear? Hello?
Yes. Got it, sir.
So answer is in terms of angstrom. Angstrom is 10 raised to minus 10.
Yes.
Angstrom is 10 raised to minus 10. So what we can do, 1.22 into 10 raised to minus 7 can be written as, 10 raised to minus 7 is written as 10 raised to minus 10 into 10 cube.
Okay, sir.
It will be 10 raised to minus 7. Here 1.22 into 10 cube. I don't want to discuss that multiplication. 1.22 into 1000. 1.22 into 1000 will be 1220. 10 raised to minus 10 means angstrom.
Yes.
So 1220 angstrom, approximately option 4. Okay?
Yes.
So look at this question.
Yes, sir.
Okay. So there is no any other new formula. Okay? Understood? This chapter is, technically speaking, this chapter is over. Okay?
Okay, sir.
Energy E of a hydrogen atom with a principal quantum number n is E equal to minus 13.6 by n square electron volt. This is familiar to us. Actually this formula is not required for us because we have studied this formula, right? Clear?
Yes.
We have already studied this formula, but they have given in this question. The energy of the photon ejected when the electron jumping from n equal to 3 to n equal to 2. Okay? Clear? So listen, this is nucleus, first, second, third. The electron is jumping from which position to which position? The electron is jumping from n equal to 3 to n equal to 2. Sorry, n equal to 2. The electron is jumping from n equal to 3 to n equal to 2. Are you clear?
Yes, sir.
If the electron is jumping from higher energy state to lower energy state, the photon will be emitted. But the question is not about lambda. The photon will be emitted, but the question is not about lambda. Question is about how much energy of the photon is ejected. Okay, listen. Yes, definitely a photon. Let it be photon. This photon will be released. The photon will be released. The energy of the photon is our question. Clear?
Yes, sir.
Energy of the photon is our question. The energy of the photon is equal to, what is the energy of the photon? Do you remember that? The energy of the photon is equal to final energy minus initial energy. Understood? Clear?
Yes.
The energy difference during the transition. During the transition, the energy difference you have to calculate. That energy difference will be the energy of the photon. Understood?
Yes, sir.
So just take the final energy minus initial energy, or initial minus final, whichever is larger. Whichever is larger. Take the difference of energy. So when n equal to 3, what is the energy of the electron? Minus 13.6 by 3 square. Understood?
Yes, sir.
You just take the energy difference, then you will get what? Energy of the photon. Take the energy difference. So when n equal to 3, the electron has the energy minus 13.6 by 3 square. Understood?
Yes, sir.
Minus. And when n equal to 2, electron has the energy minus 13.6 by 2 square. Correct?
Yes.
So you simply take the energy difference. Okay, just take the energy difference. That energy difference is the energy of the photon.
Yes, sir.
So when you do the subtraction, if you get a negative number, simply reject the negative sign, so that you need not worry about the order of the subtraction. Minus okay, so 13.6 is common in both the terms. Is it correct? Clear?
Yes, sir.
13.6 is taken outside from both the terms. Here minus 1 by 9 is remaining. Here minus 1 by 9 is remaining.
Yes, sir.
But here minus of minus becomes plus. Minus of minus becomes plus. Plus 1 by 4 is there. Clear?
Yes, sir.
So 13.6 into this calculation, you know how to do the calculation by just do the cross multiplication. 9 minus 4 will be 5. 5 by 36. Are you okay?
Yes, sir.
Then I don't want to explain the multiplication and division. You can check after the class. Multiply and divide by 36. This electron volt, you will get the answer in terms of electron volt. So you will get the answer as 1.9 electron volt. Okay?
Yes, sir. Yes, sir.
In hydrogen spectrum, in hydrogen, this is so in this question, in a hydrogen spectrum, shortest wavelength in Balmer series is lambda. The shortest wavelength in bracket series will be,
Yes, sir.
remember, in hydrogen spectrum, the shortest wavelength in Balmer series. What do you mean by this Balmer series? Balmer series means what? What is the Balmer series? This is nucleus. This is first energy state. Understood? Clear?
Yes, sir.
Then this is the second energy state, third energy state, fourth energy state, etc., etc. And this will be the infiniteth energy state. Clear? Understood?
Yes.
So the Balmer series means the electron jumping from higher energy state to n equal to 2.
Yes.
Clear? Understood?
Yes, sir.
Remember that? I explained that. Lyman, Balmer, Pascal, etc. So Lyman series means the electron is jumping to n equal to 2. Clear?
Yes,
Hello.
sir.
Electron is jumping from higher energy state to lower energy state. The electron is jumping from higher energy state to n equal to 2. We get Balmer series. Okay?
Yes, sir.
So remember, you can write it as a note for a shorter wavelength. For a shorter wavelength, electron must jumping from infinity. Okay? Clear? Clear?
Yes.
I will write it as a note so you will never forget. For shorter wavelength,
Yes, sir.
for shorter wavelength, shortest wavelength, okay, for the shortest wavelength. Clear? Understood? Depending upon the jumping, the radiation will have different wavelength. For shortest wavelength, you have to memorize this so you will never forget. Shortest wavelength,
Yes, sir.
the jumping from infinity to n. Understood? Clear?
Yes, sir.
I am using symbol. I don't want to use a long sentence. For shortest wavelength, the jumping should be done from infinity to that number. Understood? Clear? And this one also you please memorize. For maximum wavelength,
Yes, sir.
for maximum wavelength, this also you have to memorize. The jumping should be done from n plus 1 to n. Clear?
Yes, sir.
You please memorize this so it will be clear. So there are various possibilities. Clear? The jumping can be done from other energy state also, right? Clear? The jumping can be done from the other energy state to n equal to 2. So we have different types of wavelength. Clear?
Yes, sir.
We have different types of wavelength. Infinity to 2 is possible, 3 to 2 is possible, 4 to 2 is possible. We have a pattern of wavelength. Among this, for the shortest wavelength, the jumping should be done from infinity to 2. Clear? Hello?
Yes, sir.
So for the shortest wavelength, jumping should be done from infinity to that orbit, n equal to 2. Because Balmer series means jumping to n equal to 2. And if you want the maximum wavelength of the emitted photon, jumping should be done from the adjacent orbit. Clear?
Yes,
Hello?
sir.
Adjacent means 3 to 2. Understood? Clear? For the maximum wavelength, the jumping should be done from 3 to 2. Is that okay? Clear?
Yes.
N plus 1 to n for maximum wavelength. So for the shortest wavelength in Balmer series having the shortest wavelength. Balmer series having the shortest wavelength means what? Infinity to 2. Clear?
Yes, sir.
The Balmer series means 2. Understood? Infinity 2. So this is for Balmer. Understood? Balmer. For Balmer having shortest wavelength infinity 2. So the corresponding wavelength will be 1 by lambda equal to. Clear?
Yes, sir.
1 by lambda equal to r into 1 by n1 square minus 1 by n2 square. Do you remember that formula?
Yes, sir.
If you don't remember, if you don't understand, you please tell me, I will repeat. So when this jumping take place, a photon will be emitted. It will have certain wavelength. So 1 by lambda equal to r into 1 by n1 square minus 1 by n2 square. n1 and n2 will be 2 and infinity. The order of the subtraction is not important for us. So is that okay? Clear? 1 by infinity will be 0. Remember that. 1 by infinity will be always 0. So it will be r by 4. Clear?
Yes, sir.
So the the shortest wavelength is obtained when the electron is jumping from infinity to 2 for the Balmer series. So wavelength of the shortest wavelength in the Balmer series will be what? You have to take the reciprocal both sides. Clear?
Yes,
Hello? You have to take the reciprocal both sides. So if you take the reciprocal in the left side, you have to take the reciprocal in the right side also. So lambda BA means Balmer series. Lambda BA equal to 4 by r. Clear?
Yes, sir.
Reciprocal of r by 4 is 4 by r. Clear?
Yes, sir.
Next is the shortest wavelength in bracket series. Bracket, what is this bracket? Do you remember that? Lyman, Balmer, Pascal, bracket. Bracket means n equal to 4. Clear?
Yes, sir.
I explained that. I don't want to draw the diagram for bracket. Having shortest wavelength.
Yes, sir.
Shortest wavelength means infinity to 4. Clear?
Yes, sir.
Infinity to 4. Because the jumping should be done from infinity for shortest wavelength. And jumping to 4 is required because for bracket series means the jumping should be done to n equal to 4. Clear?
Yes, sir.
Lyman to n equal to 1. Balmer clear, to n equal to, like that. So bracket having shortest wavelength, the jumping should be done from infinity to 4. Is that okay? Is that okay? Clear?
Yes, sir.
So the corresponding wavelength, if such jumping take place, the photon will be emitted. If such jumping take place, the photon will be emitted, and the wavelength is given by 1 by lambda corresponding to bracket series. 1 by lambda equal to r into 1 by n1 square minus 1 by n2 square. Understood?
Yes, sir.
n1 and n2 will be 4 and infinity. Understood?
Yes, sir.
1 by n1 square minus 1 by n2 square. n1 and n2 will be 4 and infinity. The order of the subtraction is not important. If you get the negative number, just reject it. 1 by infinity 0. Understood?
Yes, sir.
So you will get r by 60. You will get r by 60. Taking reciprocal both sides. Taking reciprocal both sides. Lambda bracket series. Lambda for bracket series equal to 16 by r. Clear?
Yes, sir.
Till this step you are okay?
Yes, sir.
So in the next step, this will be the last step. So lambda of bracket series clearly 4 times lambda of Balmer series. Is it correct?
Yes, sir.
Because 4 into 4 by r is actually 16 by r. Understood?
Yes, sir.
4 times 4 by r will be 16 by r. Meaning that wavelength of the bracket series is equal to 4 times wavelength of the Balmer series. Clear?
Yes, sir.
Wavelength of the Balmer series is given as lambda. So bracket series will be 4 lambda. Clear?
Yes, sir.
2 is the correct answer.